So, is there anything unique about proportion equations that make it somehow different than what we've looked at up till now on equations? Well, the answer really is no, except you typically will see it in word problems on the exam. Therefore, it's a good idea to know the form of the proportion equations, which generally is going to be A over B equals X over Y. So whenever a word problem has a fixed proportion of elements, that's when the ratio or proportion equation is typically going to come into play. For example, so if I have 2 parts oil to 3 parts vinegar, and I ask you the question, how many ounces of oil are required to make 30 ounces of salad dressing? Well, I would want to set up a proportion equation to solve that as follows. I know the ratio of oil to vinegar in the salad dressing is going to be 2 parts oil to 3 parts vinegar, and I can set that fixed ratio that's provided to us in the problem against the actual amount of salad dressing used in total. But be careful, the ratio we're concerned about is not 2 to 3. Remember, our ratios are set up as part to part. That's the parts of oil to the parts of vinegar. But the problem tells us the total amount of salad dressing, which is the total part. So I would literally have to add part 1 and part 2, oil and vinegar, to get the actual amount of the total. In this case, it's not 2 to 3. We're actually interested in 2 parts oil to the total parts of oil and vinegar, or salad dressing. And in that case, it will be 2 parts oil plus 3 parts vinegar. And that fixed ratio is what we would want to use on this problem. And the actual amount of total salad dressing in this case would be 30 ounces. And our unknown amount of oil used for that amount of salad dressing would be our variable x that we want to solve for. So what we would do at this point is we would cross multiply. Well, let's first simplify that. So that's 2/5 equals x over 30. And we now want to cross multiply. So I'll multiply each denominator by the opposite side's numerator. And that cross multiplication is a typical first step in solving a proportion equation. Now, what are we really doing? We're actually twice multiplying by the 2 different denominators on both sides, just as we went about solving equations before. But in this case, cross multiplication does the same thing in one step. Makes life a little bit easier. So in this case, I've got 2 times 30 equals 5x. Or 5x equals 60. Divide both sides by 5 to get rid of the coefficient for x. And my result will be x equals 12 ounces of oil. And it's always important to know what that numerical value means in the context of your original word problem. So there'd be 12 ounces of oil. If I were to ask you how many ounces of vinegar, well, it would be 30 minus 12, or 18 ounces of vinegar. Another example similar to what we just saw, 1/4 is our fixed ratio, and that's equivalent to 10 parts to x. So how would we solve for that? Again, we'd first begin by the cross multiplication, and that would be 1x, or x, equals 40. And in this case, we're done. It was that simple to solve it, one step. Let's make it a little more complicated. Let's take a look at 3t minus 6, quantity over 9, equals a ratio of 1/3, or 1 to 3. So how would we solve that? Well, again, our first step is to cross multiply. And the result would be 3 times 3t minus 6. You have to multiply by every term within the parentheses, or the whole numerator in this case. And then 9 times 1 is just 9. So now I have to go through the process of multiplying out and expanding my expression with the parentheses to get rid of the parentheses. So 3 times 3t is 9t. 3 times minus 6 is minus 18, and that equals 9. So the next step I would take to solve this is I might add 18 to both sides to get rid of that constant value on the same side with my variable t. And the result would be the minus 18 plus 18 cancel each other, and I'm only left with 9t equals 9 plus 18, or 27. And now I can divide by the coefficient, as we've seen before, on both sides, and t equals 3. And that's the answer to your equation, your proportion equation in this case. Let's suppose we had x over 2 equals 8 over x. Well, what's the first step you typically take in any proportion equation? Cross multiply. Well, in this case, we get a little different result because on the left side, that's x times x, or x squared, equals 2 times 8, or 16. So we end up with a square of x, not x itself. Well, how would we undo a square? Well, we reverse that operation with the square root. So I would take the square root of both sides, and the square root of x squared is simply x, and that equals the square root of 16, which, remember, it's always plus or minus, in this case, 4. You always have the positive and negative solution because minus 4 times minus 4 also equals 16. So that would be the solution to that ratio problem. Let's take a look at another and add another layer of complexity. Again, it's a little more complicated, but the setup is very much like the problem we just saw. I will first cross multiply. So 3 times 8 is 24 on the left side. 2x times 27x is 54x squared on the right side. And I'll rearrange that to put my x squareds on the left side. 54 x squared equals 24. And we'll divide by the coefficient. 54 on both sides, at which point we've isolated at least x squared. We're not quite there to x, but we have x squared. And I can reduce 24 54s to 4/9 in its simplest form. So what will I do now? Well, I'm presented with an equation much like we saw in the last problem. X squared equals 4/9. I will take the square root of both sides to undo that squaring. So the result of the square root of x squared is simply x, and that equals the square root of 4/9, which I know is plus or minus 2/3, knowing that the numerator is a perfect square. 2 times 2 is 4, and the denominator is a perfect square. 3 times 3 is 9. So the result for that would be x equals plus or minus 2/3. Let's continue with another problem that has an added wrinkle to it. So 3x minus 1 divided by 10 equals 8 over 3x plus 1. So this looks a little different, but it's really still of the same form of a proportion equation. So I'm going to start by cross multiplying. In this case, 3x minus 1 quantity will be multiplied by 3x plus 1, and that in turn equals 10 times 8, or 80. And since I'm multiplying two binomial terms, and binomial is just a fancy word to say there are two terms added or subtracted, I would have to use the FOIL method, which means I'll multiply my first term by the other two terms in the other parentheses. So 3x times 3x plus 3x times plus 1 is just simply plus 3x. And then I'll have to take the second term in the first parentheses and also multiply it by the two terms in the other parentheses. So minus 1 times 3x is minus 3x, and minus 1 times plus 1 is minus 1. That results in 9x squared. My like terms 3x minus 3x cancel. The result is 0. And I have to include my minus 1, and that in turn equals 80 after simplifying the left side of my equation. Well, the next step might be to add 1 to both sides to eliminate the constant on the side with the x. So the minus 1 plus 1 zero out, leaving me only 9x squared on the left side, and that in turn equals 81 on the right side. Now I would divide by the coefficient of x squared in this case to isolate x squared equals 9. And again, I have that thorny little squared in our equation, but I'm going to undo that with the square root. So now the square root of x squared is just x, and that equals the square root of 9, which we might know is plus or minus 3. Again, always remember the plus or minus. Minus 3 times minus 3 is plus 9 as well. And that's the solution to your proportion equation. So as we varied the format, the complexity, the equation form still always boiled down to a over b equals x over y. So we're given in word problems a fixed proportion such as that, and then an actual amount of one of the variables that allowed us to solve for the other. And we saw how we go about solving this format of equation with a few different variations. So hopefully that'll help you get started, and good luck.